Okay guys, so today we're still going to be looking at isotopes. In our last video, we saw that the numbers on the periodic table for mass were always a decimal. And the reason that they were always a decimal is because they're a weighted average based on the relative percent abundance of isotopes. Basically, we have different versions of each atom, some weigh more, some weigh less. Well, how do we figure out the percent abundance of each of these isotopes? Turns out the answer is something called mass spectroscopy. What mass spectroscopy does is it's a machine, and this is a very, very simplified diagram, but basically what I'm going to do is I'm going to take a sample of my element, a pure sample of my element. It's going to contain a mixture of all of the isotopes. I'm going to inject it into my machine. The sample is going to start moving down through this tube. Now the first step is ionization. I know that in a regular atom, my protons and my electrons are both the same. So my positive and my negative cancel out. Well, what happens here is these little dots are a steady stream of electrons. And what they're going to do is they're going to hit my neutral atom and they're going to knock off some electrons. So now I have something called an ion. Over here, my magnesium now has this positive charge. Well, my positive magnesium gets sped up through this tube. He starts going and starts going and starts going. Well, down here, he runs into magnets. On one side, I've got a positive magnet. On the other side, I've got a negative magnet. Well, if you've ever played with magnets, we know that opposite charges attract. So this negative magnet is going to, let me change colors so we can actually read that, attract the positive ion. At the same time, like charges repel, so this positive magnet is going to push or deflect my positive ion. So what happens is instead of continuing on straight, my ions are going to start to bend. Now remember, we pictured our ions as different sizes of atoms, or my isotopes as different sizes of atoms, okay? So if I have a big mass, picture it like a bowling ball. If I have a small mass, picture it like a golf ball. Well, if I'm trying to push something, it's way easier to push a golf ball than it is to push a bowling ball. So my bowling ball, my big isotope, only gets pushed a little bit. My little isotope, my golf ball, gets pushed a lot. And so what happens is my mass spectrometer actually is going to sort out the different isotopes by mass. Everything that has the same mass is going to get picked up in the same place. So magnesium has 3 isotopes. Magnesium 24, he's the lightest. He got pushed the furthest. He'll be over here. Magnesium 25 is in the middle. He got pushed a little bit, so he's in the middle. Magnesium 26 is the bowling ball. He got pushed, but he really didn't go very far at all, so he's over here. So it sorts out the isotopes by mass, and we get something that looks like this, okay? So this is my spectrum of some isotopes, okay? In this case, it's chlorine. Chlorine has 2 different isotopes, and I can tell that on the graph because I have 2 different peaks. One peak is for chlorine 35, 1 peak is for chlorine 37. So if I look at my spectrum, chlorine 35 has a percent abundance of 75.77. Chlorine 37 has a percent abundance of 24.23. Okay? Now the first thing I'm going to do is I'm going to change my percentage to a decimal. And the way I do that is either by dividing by 100 or moving my decimal place over 2 places. So 75.77 becomes 0.7577. 24.23 becomes 0.2423. Okay? The mass is how much each isotope weighs. So chlorine 35 weighs 35. Chlorine 37 weighs 37. Okay? So now I need to find the product of the decimal and the mass. I'm going to multiply. Now when you do these calculations, the only measurement that you're looking at is the percent abundance. The machine is going to measure the percentage of each. Basically, it counts how many 35 isotopes there are, it counts how many 37 isotopes there are, and it calculates the percent. So I want you to base your sig figs off of this. Since there are 1, 2, 3, 4 sig figs, when I do this calculation, I'm going to keep 1, 2, 3, 4 sig figs. So 0.7577 times 35, I should get 26.52. 0.2423 had 4 sig figs. When I multiply him by 37, I should keep 4 sig figs. I get 8.965. Okay? Now, the last step is I'm going to add these numbers together, and that will give me my weighted average atomic mass. When I add numbers, the rule is least number after the decimal. So as I do this, okay, what's going to happen is I only get to keep 2 numbers after the decimal. So this will become 35.49. Okay? So you're going to work through these problems. I give you the mass spectrum. You're calculating the average atomic mass. Remember, your percent abundance is your only measurement, so it determines your sig figs. Now, when you get to question number 5, question number 5 not only has you calculate the average atomic mass, but they ask a couple questions. So the first one says your calculated average atomic mass, so that guy there, which is he closest to? Which isotope of chromium is he closest to? So you're going to compare your answer to this column. You're going to say, oh, my number is closest to 49.94, or my answer is closest to 52.94, or my answer is closest to 53.93. What is your answer closest to? And then you're going to tell me, based on this table, why your answer came out closest to whichever one of these masses. Okay? Question number 6 gives you a mass spectrum. It is an unknown element. It is either palladium with 2 isotopes or silver with 2 isotopes. Okay? You are going to look at your periodic table, the mass for silver and the mass for palladium, to determine whether it's going to be palladium or whether it's going to be silver. It can only be one or the other, not both. Okay? Now, really quickly, I want to talk about one more thing before you start the assignment. For both this assignment and the problems in Schoology you're going to be doing next, please check your answer and see if it makes sense. Okay? This is what I mean by does it make sense. Whatever answer I get here has to be bigger than my smallest isotope. It has to be smaller than my largest isotope. So 35.49 has to come in between those two numbers. If it doesn't make sense, and I did my math wrong somewhere. Okay? So always check and see if it makes sense. The other thing that I should do to check to see if it makes sense is if I look, remember, it's a weighted average. It should be closer to the one that has a bigger percent. So 75 is a much, much, much higher percent than 24. So my answer should be closer to 35 than 20 or 37. Because this is a much higher percent, it carries more weight, and so on average the weight will be closer to 35. Please check your answers. I always have somebody do the math and come up with an answer for isotopes where you have something like this and they tell me their answer is like 297. That doesn't make any sense. Please check to make sure it makes sense.